So welcome again all in this session. We are going to focus on the matplot in Python. The agenda of today's session is all about the learning. This techniques is mainly focusing the graphs, and we are going to demonstrate this live demo with the Python code, how we can create graphs in Python, right? And first and foremost, we need to import basic libraries like MatplotLib, PyPlot as PLT, MatplotLib and lab, which is again the module useful for different kinds of graphs. We are going to import this one. Allow me to run this code, and then we are moving towards the next plot, right? Here you can see first we have x-axis and second coordinates representing y-axis also, right? So what are these x-axis? Actually we have this x dimension and the y dimension. In the two dimension we have x versus y. So 1.0, 1.5, 2.5 and so on. So till here we have 4 points. Then we have 3, 4, 5, 6. Starting from 3 ending with 6, we have second coordinate. So x versus y total point should match here. If we have 4 points here, so the second value should be 4 again. Second coordinate must contain 4 coordinates. So there is a clear trend here that we must have equal number in both the axes, right? Then only these points will be created. Okay. So if I'm going to edit this image, you will find the point over here, right? 1 and 3 we will have first point over here, right? When we talk about 2 and 4, so we are having second intersection point over here. When we talk about 3 and 5, so we are having this third point over here. Then we have 4 and 6, so we have this 4 and 6 over here, right? So this intersection points are given over the respected values, right? So in order to obtain these intersection part, we are going to give x label here, right? You can break this down for your conversation. Like we have x values. Suppose instead of x value, let me have sales amount, right, on the x-axis. Suppose I'm having at the y-axis, I'm having profit amount there, right? And I'm going to show this values, this graph on the screen. Can you see this graph is depicting on the screen? Now if I'm going to increase number of values, let's say I'm having one more coordinate, that is 6. With respect to the same number, I'll have to increase y term also. So I'll have, let's say, 10 value. So I'm going to run the same code. Now you will find sub curve. Why curve? Because we do not have a straight line, straight coordinates. Now we have 6 versus 10. So the relationship between, if you find this relationship between 1, 2, 3, 4 and 3, 4, 5, 6 following a linear line. But particularly interesting in the last point, because we do not follow that line trend in the last dialog establishment, right? Now we have second element, adding elements to a line plots. We have TP and arrange, right? So let me generate this TP arrange in the different sections. Okay, so let me add one more code here, making it up. And now I'm going to create this adding element. So first I'll create this without 0.01. So I'm having, let me print this t also. I'm having 0 to 2.1, only two values are there, because by default it's having increment of 1. Let's say I'm having 12. So it's excluding the second number and it's giving values in between. It will give values in between 0 to 11. So let me run this code again. You will find values in between 0 to 11. It's excluding the second part, right? So here is an example of what we are talking about. Arrange function gives subsequent number for the same. So we have 0, and what is the dot representation? This dot is just for unique value, single element here, right? Now we have 0.2 instead of 12, we have actually 0.2, and the increment value is 0.01. Let's see what will be the output here. In between 0 to 2 or 0 to 9, we have increment of 0.01. Now 0.02, 0.03 and so on, right? The increment value, the third variable showing, you can break this down for your convincing purpose. We can have increment value by 0.01, right? With this t value, with the respective t value, we are going to apply sine function to the random numbers. So we have c1 plus np 1 plus np dot sine, then 2 asterisk np dot pi t. What is pi t? Let me break this down again. Here we have 2 np pi t, but c, I'm going to create one, let's say k. So I'm having this value, I'm printing k again. Can you see this k is what? K is np pi, like np dot pi. Let me print np pi separately. So we have the value of np pi already defined. It's a kind of constant value, right? So we will have quick overview of this agenda, that what kind of pi value is already stored in my compiler. We have this value as a 22 by 7, right? This is 22 by 7, right? If you will divide this value, you will get the same output, right? So the compiler, you do not have to write this 22 by 7 again. So we are writing np.by, which is by default stored the same large numbers. Now we know the value of this np dot pi is this one, 3.14 and so on. We are multiplying each value in t. We have t a list as a list, right? Each single value is being multiplied with this 3.14 value and 2. So 2 multiplied by 3.14 and t will be final output for my k string or k list, right? So does anyone having any question till here? We have entire representation for the same. Now we are going to apply this sine function to the random numbers. We are going to plot this value, and again we can see this x-axis is time in second, voltage in millivolt, and about as simple as it gets, folks, and true. And then we are going to save this number. I'm going to run this code. Can you see? Let me change this number. This graph belong to Sachin. Can you see this heading is, this title bar is now changed, right? So we have grade is equal to true. Okay, so can you see this checkbox matrix behind the graph? This representing this true value. And can I have false value here? FALCE. So if I'm running this code, you won't find that checkbox or matrix behind this graph anyhow, right? So we are going to talk about any issue that have come up regarding this grid that's relevant to the true and false. So it's a better choice that we keep it true over here, right? Now we are having very crystal clear idea about this graph, this conversation, this multiplication, right? You can see it's at point of 2 it's going to change, at kind of 0.0 it's going to change its variation, right? So we are particularly interested in because we have changes in the sine curve, right? Now here we have sine function. Let me create or add some another element. What are these elements? Let me copy the same code and let me change this sine with the cos now and run this code. Can you see? Now this course graph belong to cosine, where we have opposite direction waves, right? So here we have clear trends over there, right? If you change the function, you will get the different output. Let's say I am having 10 over here, so I'm getting the different output. Frequency will be different, right? So you can pause for a moment to discuss any question you may have in regarding cosine, sine, or sines, right? So we will discuss, we may discuss, right? But the simple trend and clear trend is here, that we are going to clear the same trend for the same, right? Okay, so our next agenda in this topic is about y is equal to 3, 10, 7, 5. So this is our first module, right? And then we are going to take this length of y is taking from the above list, and then we are going to command this range, right? And then we have weight is equal to 1 upon 1.5, and then we are going to print this graph, right? Can you see these bar plots are showing over here, right? So now we have width of the same. Let me change the width part. Let's say I am having 0.05 instead of 1.5. Let's see what would be the output here. Can you see now bar width are now changed, right? Can I have 2.5 here? So I'll have more thinner bars in my graph, right? So you can see here is a clear trend with respect to the width value with respect to 1 upon 2.5, and we can change this blue color also. Let's say I'm choosing the red one now and going to run this code. You can see now my graph is going to depict red color in a different manner, right? You can take a closer look at this graph. Like we have this changed color. Like if I'll convert into the yellow color, so you will find yellow now, and you will have better idea like plt.show and so on, right? This is called bar chart, and previous one was called simple save. Oh, okay. So I forgot to define this, illustrate this save FIG. So what is save phase? Save phase is nothing but the code, the image stored in your local machine, right? Suppose I am going to check this test. Can you see this test.png is just stored in my local machine? If I am going to download, so I can see this test image, right? So you can see that this image is just saved in my local machine. This graph belongs to Sachin, horizontal, vertically, right? And we can like you can see on this slide, like we are having PNG format, and this PNG can be used anywhere in research paper, anywhere in magazine, in printing area, anywhere in your text, your graph, everywhere, anywhere we can use this graph, right? Once we have obtained the PNG file for the same, right? You don't have manual operation like just right click on the graph and save it as per your need. You don't have that process, but rather we have already, the graph is already there in my local machine, right? This is the part of save FIG, save and already save, and FIG figure. This figure is saved with test.png. PNG is given extension for this graph, right? Now moving ahead, we can depict another value. Let's say I'm going to check this x value, right? Here is x is range 0 to 8, right? Now I'm going to generate random number, which is initially it is 50. Now with respect to random number, I'm going to generate first random number, right? So let me create these two. Let me allow me to execute these two commands in a different cell code. So can you see this x is some random 50 numbers, right? Can you see in between 0 to 1 we are having these 50 numbers 1 2 3 4 5, And how many columns do we have? Sorry, we have 5 columns. 1 2 3 4 5 6 7 8 9 10. We have 10 rows, right? So you can make sure to follow up this value. Like we have 10 rows, 5 column means we have 50 values in this list, right? So this is the method to generate random numbers for the same, right? Now we can go for the next step, which is about y. So y is again another number where we are generating 50 random numbers, right? If I click this, I run this code again, you will find these numbers are different. Can you focus at this 0.39? If I'm running this code again, now I'm having 0.94 as a first number, right? This is the reason we are giving random function here, right? Now we have, on the basis of these two x and y, I am having color random, right? It's showing random colors also, right? For pi, we have already seen these values are having 3.17, 22 by 7. And then we have np.random, again 50 numbers are generated, 0 to 15 points radii, right? Then we have a scattered function. Can you see this is scattered function with respect to 50 points are now generated, right? So this data is particularly interested because we are creating scattered number here, right? Suppose I am going to change this alpha value. So let's see one by one. S is equal to area means we have random generation area in between 0 to 15. Let's see C is equal to colors. Again, we have different colors values, right? Now alpha means we have, suppose I'm going to create this, make it 0. So we will have 0 transparency, like almost 100 transparency, right? 100% transparent, right? If I'll make it 1, so I'm having no transparency, 0 transparency is there, right? I cannot see any bubble behind the big one. So I'm keeping the optimal value for this alpha. This is 0.8 something, such that I can see the bubbles behind. If any bubble is hiding behind the big one, I can see very clearly. I can take a closer look at this big bubble where it is hiding the small ones. So this is the clear trends we are particularly emphasizing on. So we have alpha 0.8. If you are creating more values, let's say 0.5, so you will find more transparency there. So likewise, we can decrease the accuracy or the transparency there, right? Rest values we have plt.show, and rest we have different objects, right? Okay, so if you do not have any doubts, so I am going to switch to the next topic here. So the next topic is all about the pie chart, right? So here we have pie chart where the slices slices will be ordered and plotted counterclockwise, right? You can see this labels is just frogs, hogs and dogs, right? So let me make it change. Like suppose we have fishes, right? We have hmm, let's say we have like ducks, right? And then we have chicken, and then we have, let's say, goats, and we are going to run this code. Can you see this is just showing respective pie chart with their respective percentage. So fishes are having 15%, goats are 10% only, ducks are 30%, chickens are 45%, right? So we are facing this equal. Why? Because we are facing this direction in a single direction, right? What about this size, right? Size is percentage or the 15, 30, 45, 10. If you sum up of the value, let me copy this code here. and make it here and like wrap it here, and then let's say I'm going to sum. Okay, so let me have math dot sum or np.sum. Let me check. Yes, it's not working. So I can go for manual method. 15 plus 30 plus 45 plus 10. So you will find 100 as the summation of this one, right? So now we have figure 1 axis 1 plt dot subplots, and then axis1 dot pi will be my graph, and size is 15, 30, 45, 10, and then we are going to explode. So what is the explode here? Explode is the pizza portion which is coming out. In our case, ducks is just coming out, right? So we have the second portion. We can see 0.1. Let me make it, let's say 0.8, and running this code again. Can you see this pizza slice is just coming out far away from my original pizza base, right? So this is the meaning of this value. The more you will give the value, maximum can give 100, like say 1, but the more value you will give, it will move far away from your original graph. Here we have labels. So labels is like fishes, ducks, chicken, goats, and auto PCT, right? So we have like percentage, like let's say I'm having this 1.3. So we will find this the accuracy post decimal 15.333, 3 decimal up to 3 decimal will get the accuracy for the same. Let me make it, let's say 9. So we will find accuracy with the 9 decimal only. Can you see? Till the 9 decimal we are getting that kind of accuracy, but for optimal accuracy we are keeping it 1.1. You must have crystal clear idea what does this value represent, and we are going to depict this. Show shadow is equal to true. Can you see the shadow below this graph, this pie chart? We have that kind of shadow here, right? And then we have start angle. So start angle is what? Let's say you want to rotate the entire pie graph in this. So let's see, we have 0 value here. You can see now this is rotated 90%, 90 degree, not percentage, but 90 degree. If I'm having 180 value, so we will have 180 degree rotation around this value, right? Can you see? Similarly, you can have 270 degree. According to your case study, you can rotate the entire graph here, right? Then we have x is equal to 2 for equal aspect ratio. Ensure that pi is drawn as a circle, right? Let me make it comment and let me circle. Can you see this? Something is different here. Something different accuracy is now changed, right? Do we have any question till here? Which means we are good to go to move ahead. Lastly, we have sample data 1, 2, 3, 4 and 2, 4, 6, 8. Then we are going to create this scatter plot. Let me run this code. It's a simple one. Let we have two values, two coordinates, x and y, and then we can create this scatter plot, right? And you can see this is just rotating in the entire xy plane, right? Sample scatter plot, right? We can go for the 3D graph also. Let me run this code. Okay, I think it's not showing any graph, but here we have that value, that graph, but there might be some minute mistake, iota of mistake will be there, and we can solve it out, and then we can go for the 3D graph, 3 point of value, right? So here can you see x, y, z, 3 values are there, and we are going to create this subplot projection 3D, and bar 3D values are just here. We will have to define x-axis, y-axis and g-axis in a same pane, and we are going to create this conversation for the entire title. A simple 3D bar graph will be created, and you can display the plot using plt.show, right? So this was all about the matplotlib in the Python. If you have any query, you can note it down. You can write in the comment section. We are creating this graph with the help of matplotlib library. Other functions are also available on their official website. You can go and check it out what other functions are available for the same, right? But you can create graphs in Python using these basics functions, and you can go for the different aspects also.